Hello again, and welcome back, class, to 4.3 representations of linear relationships. This time it's partial variation, and we'll see how this is slightly different than what we learned from 4.2. It's set up almost the exact same way, except for different stories and different tables of values, and we'll see how this is different, and I'll point it out as soon as we get to it. Let's jump into example 1. The story is Sarah rents a car and drives a distance of 300 kilometers. She's charged $25 up front and 50 cents for every kilometer driven. Create a table of values to track the costs of the rent of the car. For this, we're just going to set it up exactly where we set up our last table of values in the last lesson. In this case, though, distance is going to be our independent variable. And the reason why it's going to be our independent variable is because the cost depends on the distance. Well, how much does it cost to rent the car? Well, it depends on how much you drive, really. Remember, when she drives 0 kilometers, she's charged $25 up front. So if she doesn't drive at all and she rents it, it's $25. Then it's 50 cents for every kilometer driven. Well, if she drives 50 kilometers, I'm just going to write this down below because that's where I have some free space. 50 kilometers times 0.5 because it's 50 cents per kilometer. Well, what's 0.5 times 50? Well, that should actually just be 25. So for every 50 kilometers, it'll cost her an additional $25. So when we drive 50 kilometers, well, 25 plus 25 gives us 50. Because you start at 25, then you add 25 to it. So to go from here to here, you get to add 25. I'm going to erase that later, but I'm just doing it to illustrate. And then we drove another 50 kilometers, which means we add another 25, and we get to 75. So add plus 25. Whoops, plus 25, not 5. And again, drove another 50 kilometers. That means another $25 on that. Plus 25. You should see a pattern. Drive another 50 kilometers, add $25. Drove another 50 kilometers, add $25 again. Drove another 50 kilometers, add $25 one more time. Okay, perfect. I'm going to erase those lines once I get to the graph, or that rough work once I get to the graph, to just demonstrate how we got there. You don't need to copy that down. So in this case, the independent variable on the left is our distance traveled. Our distance traveled. The dependent variable is the cost. And the rate of change, well, our rate of change is $50 for 100 kilometers driven. Or 5 over 10. Or 1/2 is our rate of change. The initial value is $25, which means that our rate is equal to 50 cents or $0.50 per kilometer. Which means our equation looks like this: 1/2 times x, like we did before, right? But because our initial value is different, we actually start at 25. We actually have to add 25 at the end. Whatever our initial value is what we have to add at the end, and that's found at the very first section of our table of values. Okay, now I'm going to clean this up a little bit, and I'm going to draw out our graph. I'm going to pause to do this. and then you can just copy it down and follow along and pause the video if you need to. Okay, and there we go. Just try to follow along. It says cost along the vertical axis there, and then along the horizontal it's distance. I just jumped a few things. Let's plot out our points. We have 0, 25, which would be here. Then we have 50, 50, so 50, 50. Then we have 100, 75. 150, 100, 200, 125, 250, 150, 300, 175. There we go. And now we draw our line straight through. Remember to use a ruler for this. Again, I can't really use a ruler on a tablet. Otherwise, I would. To demonstrate this, I'm just going to use a line tool. And in order to do that, I'm going to pause my recording. And I'm back with my line here. In red, of course, because that's the color of the pen by default. And I extend it, and I have an arrowhead at the top because you can still drive further than 300 kilometers. However, it will cost you more. So this graph does continue onward. So make sure you include that arrowhead at the very end of your line on your graph. Okay. With that said, let's go to the next example. In example 2, this is going to work a little bit different. We have a candle that is 16 centimeters tall. It burns down 2 centimeters each hour. Okay, we need to create our table of values, which we have over on the right in the center of this whole thing of our notes. And we're going to track the height of the candle at each hour. In this case, we're going to track every 2 hours. So we're going to go by hours. And then the height, because the height's going to change depending on the hour, how many hours it's been burning. So if we have 0 hours, it's 16 centimeters, right? Remember that each hour it burns 2 centimeters down. So if we go 2 hours, well, it's just going to be 2 centimeters per hour times 2 hours. So that's going to be 4 centimeters down, right? And it's burning down 4 centimeters, so we're not going to add it to 16. We're going to subtract it from 16. So what that means is we're going to have 12 centimeters here. Next, we take a look at 4 hours. Same idea. 2 centimeters per hour times 4. Well, 2 times 4 is 8. So we're going to subtract 8 away from 16 because that's how much we started with. And then it burns down 8 centimeters. So that means we're going to be at 8 total. What about at 6 hours? Well, we're going to, how much of the candle is going to melt? 2 times 6, which is 12. 16 subtract 12. That should give us 4. Then at 8 hours, finally, well, 2 times 8 at the bottom there, 16. 16 minus 16 is 0. There's a lot going on here. Notice that we're decreasing every time. And the independent variable is time, or hours, because the height depends on the amount of time that it was burning. The longer the candle burns, the shorter it gets. The rate of change is actually minus 4 centimeters for every 2 hours. So it goes down 4 for every 2 hours. If we reduce this, you use your ABC button, you should get -2/1, or just -2. That's our rate of change there is -2. So for every hour, it goes down 2 centimeters. Just like it says in our question, it burns 2 centimeters each hour. Our initial value is 16 centimeters because we start at 16 centimeters. This is also known as our y-intercept. Our rate is 2 centimeters per hour. So the equation here is y equals our rate of change, which is just over on the left, -2x, plus our y-intercept. What do we start at? We start at 16. So y equals -2x plus 16. Perfect. Okay, I'm going to set up the graph, and then you guys can pause it and copy what you need to. Okay, now my graph is set up. We're going to plot our points, and then we're going to draw a line straight through it. At 0, we have 16 centimeters. So at 0 hours, we have 16 centimeters because it hasn't been burning. After 2 hours, we'll be at 12. I'm just pulling these values from the table of values. At 4 hours, we'll be at 8 centimeters. At 6 hours, we'll be at 4 centimeters. And at 8 hours, we'll be at 0 centimeters. Okay, I'm going to draw a line through this, and then I'm going to talk about it a little bit more. So I'm going to pause the video, or pause the recording. Okay, we're back, and we can see the line doesn't have an arrowhead. That's because the candle can't grow further, and we can't have negative time. And it also can't be less than 0 centimeters. We can't burn beyond 0 centimeters of the candle. Otherwise, we would be burning past whatever it's standing on, and that just doesn't work in a real life scenario. Okay, so our note for a partial variation relationship is an equation of the form y equals mx, just like we had before, but now we have plus b. And the b is your initial value, whatever you start with. M is your slope or your rate of change. And x is your independent variable, y is your dependent variable. Okay, and that should be everything for 4.3. You guys should be able to work through the rest of the practice questions and then give the quiz a try. If you have any questions, you can always email me. Best of luck, and I will hopefully hear from you guys soon. All right.